Welcome and hello. This is a video exercise in HEC HMS. And in this exercise, we are going to be working with creating paired data sets. All right, what I have on the screen here is an empty HMS, but I want to put up the website here. So this is the page that you can link to in the description. It'll be the first link. And this is going to be the page with our starting files and instructions for completing this exercise. All right, so go ahead and join me if you want. If not, just enjoy the show. Creating paired data. What we first want to do is download the initial files for the project. So we're going to scroll down just a little bit here and click on this shared component data overview page. And then once we're there, we want to scroll down just a little bit until we get to this project files. There's an initial project files, and then below that, there's a completed or final project files. So go ahead and click on the initial project files link, and then click on the download button, and then wait for that to download. Okay, so that's downloaded for me. I'll just go ahead and close that. And what I want to do is open up that file and see what we have. Shared plus component data, punks directory, and then inside the punks directory is where we have the HMS files. So I'm going to go up one level here and then find a place on my computer I want to store those. So I'll just move them over to my permanent place for them. All right, so that's copied over and unzipped, and now I can delete the zip file as well. Now in HMS, I want to go ahead and open up that project. So I'll go ahead and click the open button and then click browse. Here is the punks directory. So I'll click on that. And then inside that directory, we have this punks.hms file. Click on that and then click the select button. All we have is basin models directory, and we have one basin model. So not a whole lot going on here, and that's fine. I'll expand the basin model just so we see it here in the map display. If I return to the web page that we were on where we downloaded the files, when we click that link to download, it actually sent us to a different page. So we started here on this creating paired data. This is the first link in the description of the video, but then it sent us to this overview page to actually download the files. So let's return to where we started here. Click on this creating paired data page, and this should look familiar. I'm going to go ahead and change the width again. Okay, there we go. It's a responsive web page, so if the browser is wide enough, you'll get that side menu. But all right, let's get started with the instructions. We've already gone ahead and opened up our project, which is the start. And now we're going to start adding some paired data sets. The instructions here only give one example, so I'm going to add a couple more at the end. And what we're going to be doing in this exercise is adding 3 paired data sets to our project. The first one here is in the online instructions, and that is going to be adding an elevation discharge curve manually. And then after that, we're going to add a cross section manually, and then an elevation storage curve using a DSS path reference. So let's get started. Step 2 is create a new paired data function by going to Components menu and Paired Data. Okay, so what that looks like is right here in HMS. We'll go Components, Paired Data Manager, and what I want to select here is going to be Elevation Discharge Functions, which is this one right here. So this would be for like a weir or a spillway or an outlet. We'll go ahead and click New. For the name, we're supposed to put interpolated rating curve, all right, and then click Create. There's also a description that you can add if you want, and then we'll click Close to the Manager. Now up here in the Watershed Editor, we have a new directory for our paired data sets. So we can expand that, and then inside our elevation discharge functions, we have the paired data set that we just created. Now we haven't added any data to it yet, so that's what we're going to do. For data source, we're going to keep it at manual entry and then make sure the units are in feet in CFS. So for a rating curve like this, the elevation of the water up in feet represents a certain flow rate in CFS. The instructions tell us that I'm on step 6 now. The data is provided in a CSV file. So if we go back to those files that we downloaded, here's the punks directory. And then inside the data directory, there's this Mahoney_rating.csv file. Go ahead and open that up. And it's easiest to actually open it up in Excel. If you open it up in a text editor, it won't necessarily parse or be easy to copy. But here in Excel, we have our stage and discharge. So this is the elevation in feet. This is the discharge in CFS. I assume it's CFS in feet. It doesn't say that, but let's just go with it. So what I'm going to do is just highlight all these rows and columns. all the table data and then copy. Let's return back to HMS right here. And then in the table data, this is referring to our rating curve that we created. I'm going to just select the first record here for feet and then right click and paste. All right, so our data is now in here in the component editor, the table tab, and that looks good. I'm going to click the save button. And then just to check to see what it looks like, I'm going to click this graph tab. And here we have the data that we expect to see. We have elevation versus discharge. In the table tab right here, the data we pasted in, the instructions make a note that it's important for the paired data values to be strictly ascending, meaning they must be increasing, going downward, and cannot repeat. So that's probably referring to like this elevation. We need to have increasing elevation values as we go down this table. Now I'm on step 11. We can verify that the curve is available for estimating the stage elevation by opening up the basin model, which we already have here. And let's go ahead and click on the outlet element. So here's the basin model. If I expand that, the outlet is right here. Okay. Now in the components editor, if I select the options tab, we have this stage discharge dropdown, and I can now select interpolated rating curve, which is the interpolated rating curve right here that we just defined. If you're following along on the instructions, you'll notice that we are at the bottom here. So that was the last step, 12. And then you can download the final projects if you want. But just to give a little bit more exposure to this topic, I wanted to add a couple more paired data sets. So let's go ahead and do that. Let's go up to the components menu, paired data manager. So what we've already done is elevation discharge. That's this one right here. But as you see, we have all sorts of options for paired data sets, which are used in all sorts of different places in HMS, such as storage discharge, elevation storage, elevation area. These are some reservoir functions, unit hydrograph curves, percentage curves, cross-section curves. Some of these are a little bit more robust than others. Elevation width, elevation parameter. I'm not going to read them all, but let's just find a good one. I said I was going to do cross-sections. So let's click on cross-sections and then click new. Now let's just go ahead and give this a name, cross section, and then this is going to be for a reach. So I'll just use the reach we have right there. It looks like R10, something like that, and then click create. I'm going to close the manager here, expand the paired data, and now we have a directory here for cross sections. All right. Most likely for cross sections, we would have the station number along the length of the reach and maybe the reach name as well. But we're only going to be building one cross section. So the name is by default unique. All right. So what do we have down in the components editor? We're going to do manual entry again. And then the units will go with feet and feet. So the first feet is the independent variable representing the stationing across the cross section. And then the second feet value here would be for the elevation. If I click on table, now we have a predefined number of rows here, which is 1, 2, 3, 4, 5, 6, 7, and 8, representing the 8-point type of cross section that we sometimes see as a simplification of an actual cross section. So oftentimes you may have 20, 30, 50 different points defining a cross section. But if we only have 8 points that we can define it here, then we have to make our best approximation using just 8 points. Exercise 17 in this playlist gives an example of exactly how that works. So go ahead and check that out. It's titled Cross-Section Paired Datasets, and I'll leave a link to it in the description. All right, so anyway, here is our table tab. Let's go ahead and just type in some numbers. So I'm going to start with a station of 0, and then this would be looking upstream, left to right. So elevation would be 70, 30, 40, 60. Those are my station values. Okay, so I just made up some numbers there. I'm going to click save, and now I'm going to click on this graph tab just to kind of do a visual inspection and make sure what I typed in, I didn't make any typos or anything. And this looks appropriate in what I'm looking for. So we'd have like a main channel area in the middle and with a left overbank and right overbank. Now we're ready to assign this cross section to an element in our model. So what we're going to do here is click on the reach. And then what I want to do is click on the routing tab. And just kidding, I need to select a routing method that accommodates the shape of the reach itself, which there's a few of them, but I think Muskingum Kung does. So I'm going to select Muskingum Kung for my routing method and then click on the routing tab. And perfect, here we go. I have a shape for the cross section, and I can define the dimensions of the shape. But what I want to select here is 8 point. And then now I can specify the cross section right here, which is right here, R10. This is our cross section pair data set that we created, and now it's assigned to this reach. All right, that was the second pair data set. The third example is going to involve linking to a DSS path. And let's get started with that. Let's go up to Components, Paired Data Manager. I can also create a paired data set by going Create Component and then Paired Data. But what I'd have to do now is specify the type in this dropdown. So it's basically the same thing. What I'm going to do is create an elevation storage curve. So this would relate to reservoirs. Right here, the second one, elevation storage functions. I'm going to call this reservoir 1 storage. Okay, so this would define the geometry of a reservoir and click Create. All right, up here in the Watershed Explorer, I'm going to expand my paired data. Elevation storage is this first one. And here is the paired data set I created. Now, instead of manual entry, I'm going to select DSS file. And now I need to navigate to my DSS file. Now, I don't have it created yet, so let me go ahead and back out and make that data in a DSS file. To do that, I'm going to open up DSS View. Now that's open, I'm going to go up to, let me just create a separate DSS file for reservoir 1 data. So File, New, I'm using version 6. Here's the project. I need to navigate to where I want to put that DSS file. Hunks. Let's put it in our data directory. In here, I'll just call it reservoir 1 data. Okay, it's been created. We have a little tab up here representing that file. Now we want to create our paired data set. So we'll just do a manual entry, paired data set. For the path name parts, I'm just going to be generic and say the name of the project, the location. The independent variable will be the elevation and then storage. I'll just leave parts D and E empty, and then I'll call this reservoir 1. Okay, that looks good. It'll be one curve, x-axis. The units for elevation will be feet, and then for the storage, that'll be acre feet. Okay. Now, what I want to do here is actually type in the elevation values for the x parameter, and then after that, the corresponding storage in this second column, which is the y value, the dependent variable. I have a spreadsheet that I prepared for this exercise, as well as a number of HEC ResSim exercises. So if you're interested more about reservoirs, I'll leave a link in the description to my playlist on HEC ResSim Lessons. But anyway, I'm going to just highlight the data for elevation and storage in feet and acre feet respectively. This is another Excel file, obviously in Control-C to get that data. Now I'm going to come over here. I could right-click paste or Control-V. I believe those both work, but there's also a paste button, which has always worked for me, really. And here is my data. So if I scroll down, I've got it all there. That's good. The elevation ranges from 1350 up to 1500 feet within the corresponding storage values right here in acre feet. So I'll click Save. What it's asking me here is, do I want to return to this data entry screen? The answer is no, but I do want to click on the path and just take a look at that data. And then here is the plot here. So as the elevation increases, so does the storage of the reservoir. All right, that looks good. I can also get the data again, just right here. All right, I'm going to minimize DSS view. We're now back in HMS. It's time to make that assignment. So what we can do is click on our storage discharge paired data set up here. Just make sure we're selected and then browse to that DSS file. Here is our project, punks. And then in the data directory, I now have this reservoir1data.dss. So I'm going to click select. And then for the path name, there should only be one path in here anyway. There it is. And then set path name. All right, so the units came in. I'm going to go ahead and hit save. And that is how to define the geometry of a reservoir. We don't have any reservoirs in our basin model, so let's just go ahead and add one for the sake of assigning it this geometry. I'm just going to put it, how about right here? It doesn't matter. Reservoir 1 is the fine name. And then I'm going to click the arrow tool, click on that reservoir. It's right here in my Watershed Explorer. With reservoir selected up here, I'm going to come down to my components editor. So I need to change the storage method to something that involves the elevation. So here's elevation storage right here. And then now I get to define that elevation storage relationship, which is a paired data set which is right here. All right. Well, that was it for this exercise. We talked about paired data sets with a few different examples here. We dealt with elevation storage, elevation discharge, and cross-section. Of course, there's others. And we also demonstrated the manual entry as well as referencing via a DSS path.